Hello and welcome to the Daylighting in LBTools series. In this video, we will review how to take prepared geometry and use the annual daylighting recipe to evaluate lighting quality in a space. So let's get started by going to Grasshopper. I'm starting with a script that already has the geometry set up. There's a video on this. If you've missed it, please check that video out in the Daylighting series, how to set up your geometry. We are working with the room by room approach, and the grid is already set up. And we also have already in the canvas a panel that contains the URL for a weather file for Boston and the download weather component from the Ladybug tab. So to get started, let's go to the Honeybee Radiance tab and go to Recipes and bring down the annual daylighting recipe. Similar to the point-in-time study, the first input for the annual daylight recipe is a model. And the next input is a WEA. So if you're not familiar with this input, a WEA is a type of weather file that can be generated from an EPW file. So if we have the download weather file component, we can go to Light Sources and select the HB WEA from EPW component. And what that will do is it will take the EPW file and convert it into a weather file for an annual daylight simulation. So this is different from the point-in-time simulation because we're not studying 1 hour of the year, although this component allows you to do that by connecting hours of the year using the LBTools analysis period component. For an annual study, most of the time you're going to be studying the whole year, and so that's what this component will generate. Okay. The next input that we need to connect to switch the component from being orange is a toggle, which will allow you to run the study. There's a couple of optional inputs here that we can talk about. So north would be if your model is not set to true north, then you can indicate where north is if you're using Project North or something like that. The next input to be mindful of is the thresholds input. So the thresholds are tied directly to the daylighting metrics that are output from an annual study. So we have daylight autonomy, we have continuous daylight autonomy, and then we have useful daylight illuminance. So these are the three main metrics that are calculated when simulating an annual daylighting recipe. You can use the results from a daylight autonomy study to calculate spatial daylight autonomy for lead purposes. For now, if we go back to the thresholds, we want to make sure that the defaults are actually in line with the most typical outputs. So it's using 300 lux as the threshold for daylight autonomy, which would be a typical assessment for lead, especially for office type buildings. And where the thresholds are also set to a lower threshold for UDI of 100 lux and an upper threshold of 3,000 lux. So if you're familiar with the UDI metrics, there are three ranges that will result. The main UDI itself is going to be daylight values between 100 and 3,000 lux. Anything under 100 lux would be UDI low, and anything above 3,000 lux would be UDI up. So you can use the UDI low to identify areas of a space that are too dark, and you can use the UDI up as an indicator of areas that might have potential for glare. So if you want to change the default thresholds from 300, 100, or 3,000, all you have to do is create a string of text using a panel. So you can set -T is 50 if you want to study a threshold of 50 lux for daylight autonomy. And if we go back and just check, I believe it's LT and UT for the lower threshold and the upper threshold. So we can do negative LT as, if you want to study everything between 200, and for the upper threshold, we would possibly put anything above maybe 2000 and hit enter and connect that panel to the thresholds. So this will then calculate daylight autonomy for 50 lux, and it would change the lower threshold for UDI to 200 and the upper threshold for UDI to 2000 as it runs the calculations. The next input that is optional and recommended is to connect a schedule. You can connect, there's several different ways that you can connect a schedule. You can go to the Honeybee Energy component tab and create a schedule, a custom schedule, or you can search from a Energy Plus schedule and use that schedule. So if you're in a generic office space, you can type in generic office schedule, and that is tied to an Energy Plus schedule and connect it there. Again, this is an optional input, but it would be required if you want to run a spatial daylight autonomy study, since that study requires an occupancy schedule to evaluate the quality of daylighting. And similar to the point-in-time study that we reviewed in another video, if you're an advanced user and you want to change your radiance parameters, you can connect a text string with the parameters that you'd like to use, or you can go to the Honeybee Radiance recipes and select radiance parameters and modify it accordingly in using this component. You just want to make sure that because this is an annual study, your recipes type is set to 2. So the slider would not be at 0, which would be a point-in-time study. You make sure that you change the type to 2, and you can select your study resolution as low, medium, or high. Just remember, the lower the detail, the faster the study, and higher the detail, the slower the study. And if there's even more advanced users, you can still start with a detail level and modify just a few of the radiance parameters. If you connect a panel to the output for radiance parameter, you can see these values in that output. So if you're an advanced user and you know that you want to keep all of the parameters the same, except you might want to increase your bounces. So you can say negative AB to 4 and connect that as an additional parameter, and that will automatically change that to 4, as you can see in there. So again, that's for advanced users. You can also just you can copy one of these outputs and create a new panel that has all of them and just change one of these, and connect that as a text string to your radiance parameters. That all 3 of those options will work. For now, I'm not going to add any. I'm just going to use the default radiance parameters that are, I believe, set to like a medium study. And before we start running the simulation, I just want to make a quick change here. So generic office should be generic occupancy. And I'm also going to remove the custom thresholds, and I'm going to leave it default. So that's 300 for daylight autonomy, and then it's using the 100 to 3000 for the UDI scales. So let's let that simulation run and see what the results look like. When it finishes running, let's see what we see in Rhino. There's nothing here. And that's because, similar to the point-in-time recipe, you have to post-process the results and go to the Ladybug tab and bring down a spatial heat map component, and this will allow us to visualize the results. Now, annual daylighting recipe is a little bit different than point-in-time or the grid-based studies because there's a couple of different metrics that are output. So what we're going to do is we're going to set it up for daylight autonomy, and then replicate it and change the data points so that we can visualize all of these outputs together, or at least everything but continuous daylight autonomy. We're just going to focus on daylight autonomy and UDI in this video. So what we want to do is we want to actually flatten our data using a grasshopper component. So we'll take the data, because we're testing multiple rooms, so I'll hit flatten. We want to make sure that we can read the results accurately and not get an error. And we'll use a mesh join component to join the meshes from each room as an input. So let's go and find our mesh output. This is right here. So there's our meshes. And once we connect these two, we can go to Rhino and see what it looks like. There you go. Now we can start seeing our results. What you'll notice is that there's a little bit of a haze or like a darkness to the results. To fix that, we'll go to Grasshopper, and this mesh component, we'll turn it off, because if you're an experienced Grasshopper user, you'll know that every time you transform some geometry of any kind, it'll create copies of the same geometry with its transformations. So if you don't want to visualize every transformation you've made to a geometry, you have to make sure you turn it off as you go from left to right in your script. And I'll show you another example of that as we get to the rest of our script. So let's go back and take a look at it. Yeah, see, that's much brighter. I'm going to switch to top view here so that we can see the legend more clearly. This legend goes from 2% to 72%, and it's always in percent, right? So because we're assessing the daylight quantity at each sensor point over the course of a year, the results are not lux as they are in point-in-time studies. They are percent of the year, and that's true for every single metric in the annual daylight recipe. So we want to connect the legend parameters and make some changes to the legend so it's consistent with percent of time. So let's go back to Grasshopper. And in the Ladybug tab, there's the legend parameters component. We do have a video for legend parameters in the climate analysis series. So I'm not going to go into the details, but I will connect the legend parameters, and I'll do a side-by-side here so we can see the changes as they occur. And we'll set the minimum to 0%. We'll set the maximum to 100. And because this is going to be an even increment of 10, 11 segments, we can remove the decimal places. So just to clean it up a bit, I'm going to set the decimal places to 0. And there you go. So it's starting to look a lot more cleaner. And then the next two things we want to add is a legend title to the color map for the legend. And that's going to be percent. So you can do a percent symbol, or you can type in percent, whatever your preference is. And we'll add another panel that says this is a daylight autonomy study. So we'll just hit daylight autonomy, connect that as a global title, so you can see it added it right there. You can also change the colors if you want to. So you can use the, in the Ladybug extra section, there's a color range component. So if you drop that down, it has an index of 26 different colors that you can connect. So you can do 0 to 25 as a slider, and you can toggle through it to change the different colors. So it's just ability to change how it's visualized. Okay, so let's move this over, and we're going to copy this 3 times. We're going to make 3 different copies. So in total, we'll have 4 results. Okay, and what I'm going to actually do is I'm going to delete the color index for each of them. And I'm going to change the titles and reconnect the data. So for UDI, we want to connect it to the data input here, right? So we just change that to UDI, and we can change the title so that it's UDI 100 to 3000. And okay. And you'll notice that each copy of the spatial heat map is on top of one another. And that's just the way that it is by default, because if you want to see them side by side, we're going to use a move component to move them. Let's finish setting it up, and let's add a color swatch here because I like to use very specific colors for UDI, and that's just a personal preference. So you can connect, you need a minimum of 2 swatches, and I'll change that to be green. And you can just choose whichever green you want. You'll hit Shift to connect it. And then let's move this mesh so we can see it next to the daylight autonomy. The way to do that is to type in move and find the native grasshopper component for move. And we'll take the mesh. So there's a couple of outputs that we need to move. We need to move the mesh. We'll hit Shift and we'll connect the legend as well as the title. And let's minimize this so we can see what's happening here. Oops. Nothing's happened yet because we need to give it a action. So we need to give it a motion. You can type in unit, so you can connect a unit vector or a unit in a specific direction. So unit Y would be if you want to move it up or down. Unit X would be if you want to move it right to left, and that's what I want to do. So I'm going to click on unit X, and I'm going to measure. Let's just take distance in Rhino and just see approximately how wide my geometry is. So it's about 28 meters. So I'm going to use increments of 30 to move the geometry to. So we'll click that. And there you go. So now you see that at least the UDI 100 to 3000 has moved over. So let's do that for the rest of the geometry. Let's copy that and move it over. Or, yeah, actually, you know what? We will just copy the whole thing and move that down. So here we're going to change the color. Well, let's change the data first. So we're going to take UDI low now and connect it here. And we will change that to the color blue. Okay. And we'll change the title so that it's UDI 100, like less than 100. And we'll change the unit that it's moving to 60 because we want it to be next to our green UDI. And we'll copy that again. And this last data input will be UDI up. So this is going to be the upper threshold, which is greater than 3000. So let's make sure we update this title to say greater than 3000. And we can go ahead and change the color here. And I'm going to change it to a red and hit accept. And we'll change the location so that it is at an increment of 30 would equal to 90. Now let's go back to Rhino and see what's going on. All right, so now you can see that we have the 3 that we moved next to each other, but the original ones are still on top of each other, and that's because we have to turn off that color mesh for the 3 UDI scales because daylight autonomy is the only one in its original position. So we can click on the mouse wheel and turn the preview off. And then go back and see. There you go. Now we can see daylight autonomy next to UDI, UDI low and UDI high. Okay, now the last thing I want to do is take this daylight autonomy visual and assess the spatial daylight autonomy, which is a lead metric that looks at the same threshold that we used here, which is 300 lux, but it adds the component of time to the evaluation. So it says, how often or how much area within this space achieves 300 lux for at least 50% of the year. Okay, so we're going to add a component to our output. So what we're going to do is go back to our daylight autonomy results, right? And we're going to go back to the Honeybee Radiance tab, and in the results section, there's a component for HB Spatial Daylight Autonomy. So we'll drop that down onto the canvas. And it has the same inputs as the color mesh, right? So we're going to connect the data that is coming from our annual daylight simulation and the mesh, right? And then this last input is that time component of the calculation, right? Because your annual daylight recipe already establishes the threshold at 300 lux, or whatever you changed it to. If you're assessing a different metric other than lead, you can change that from 300 to whatever you want. But given that it's already set to 300 here, now this component, the SDA component, adds the time component. So this target DA is actually where your 50% of time is incorporated, and that's the default value under target DA. So once you connect the data results and the mesh, which will calculate the area, your SDA will be reported automatically as an output of SDA. So you just connect a panel there, and here we are. So our building is for 88% of the year is daylit according to the SDA calculations. So now you know that, if 90% I think is an exemplary point, right? So if you want to go back and adjust your design, you can go to your design and start evaluating your dark spaces, right? So if we look at our UDI and our different thresholds under it, we can say, oh, this is really bright. Maybe we might want to add a little bit of shading, and maybe this corner where it's really dark, we can open up the windows a little bit more to make it brighter, right? And you can see that in the daylight autonomy as well. You see like really bright spots. You know that that's getting greater than 3000 because of the skylights, and you know that these darker spots are darker because we have a really small window that's high up in the space that's not necessarily getting any light down into this space. So it might benefit from maybe a window over here or making this window larger. But those are all design strategies that you can evaluate and study in order to bring your daylighting levels higher. So that's all I have for you in this video. I'm looking forward to seeing you in our next video. Thank you.